Hey guys, welcome back to my channel, and today we are going to talk about one of the interesting projects in Terraform, that is creating VPC using Terraform and then deploying this Terraform code using GitHub Actions as a CI/CD pipeline. So this is really going to be a wonderful project for your resume as well, so that you can showcase your work in Terraform. Yeah. So basically in this project we have created not only VPC but other components of VPC like subnets, then internet gateways, then route tables and EC2 instances along with load balancers as well. So before actually jumping into the Terraform code, what I thought is I should give you a brief overview of these components, like what is their relevance and uses, so that you get a brief idea like what are we actually going to create, right? For them, those who know about it, they can directly skip it and move on to the coding part. So without wasting any time, let's get started. So the first thing that we are going to discuss about is a VPC. So basically, what does VPC stand for? So basically, VPC stands for Virtual Private Cloud, right? So basically, we have got an AWS cloud, right? Now, this AWS cloud has got a wide range of networks made available for you to use, right? But if you are going to create a project, yeah, if you are going to create a particular project with specific requirements in it, you can't directly go and create anything you want in the AWS cloud. For example, let me give you an example. Consider that this is the area of Pune. Okay, now if you want to build a house or whatever things you want to build, suppose you want to build a building or a storehouse or whatever, so you can't directly go anywhere and do anything. Yeah, you require a specific area to acquire first, right? So what you will do is you will go and search for a land area for yourself, which may be in acres or hectares, right? Depending upon your requirement. So you first allocate a particular area for your usage, right? And then you start creating your house, your storeroom, your guest room, your garden, and etc. Right? You don't directly go and build anything anywhere, right? So you are allocating a particular space for you to uh, have your resources, right? Similarly, in an AWS cloud also, if we want to create a particular project with specific requirements, then in that case, we need to assign a particular address range for that particular project. Simple. So, simply what we are doing is we are logically kind of isolating a network space. For us to work upon. Okay, simple, isn't it? Now over here you can see that we can create multiple VPCs in a single cloud within a region. Okay, so in a VPC you have got a full control of whatever you do over here, right? You also assign a specific IP address range to it, which is also known as CIDR, classless interdomain range. Okay, so we don't need to go deeper in this. You just need to understand that a particular IP address range is being allocated to this particular VPC. Within that range only you are going to allocate resources for that particular range only. Okay, so let us consider that this is one VPC, say VPC 1, and this is another VPC, that is VPC 2, and suppose this VPC is assigned this particular IP address, and the other one, let's say 20.0.0/16. So this is particular CIDR range. This is just for an example, like how um, we assign these ranges. This is the way that we assign. While writing a Terraform code, you will notice it that how are we going to specify the CIDR ranges as well over here. Okay, so this concept is quite simple enough. You just need to keep in your mind that it is a logically isolated network space designed to use for a particular or specific project where you get a full control over it, and you need to assign a CIDR range to it. Simple. Now let's move on to the other topic, that is subnets. Now what are subnets? Yeah. So basically you can see that this name itself has got two meanings. That is, sub stands for division and net stands for network, which means that there is a division of network. Now in this case, which network are we dividing? We are dividing a VPC. So there was a whole AWS cloud. We specified a particular range as a VPC, which is our virtual private cloud. If we assign a particular project to a particular VPC, then within that project, we have multiple applications to work upon. Simple. Now, these applications may not require the direct internet access. They may require sometimes, they may not require sometimes. For example, if we want to create a database, then we don't need this database to be accessed publicly, right? It needs to be in a private subnet. Whereas, whereas if it is a public subnet, suppose it is a front end application, then in that case, it has to be public since the internet accessibility is required over here, right? So in this case, we require a public subnet. So the distinction of a particular um, IP address range for a particular kind of function. Yeah. So for that purpose, we require subnets. Simple. So this is just the division of VPC. Yeah. With further, for example, if this is my CIDR range, right? Then you can take it as this /24 because you are not using the whole VPC. You are using just a small IP address range, right? So that is the thing. Okay, simple. Now you may be getting confused with what is this. For this video is specifically for the Terraform code, so I won't be going much deeper in this, but you should have this basic knowledge of CIDR and subnets and network ID and host ID. So you must know these concepts so that you will be easily able to understand like what all things are happening over here, how this division of networks is happening. Okay. So for that, I would recommend you all to first go through these networking concepts first so that you get a clear idea about it. Then you will easily understand the things over here. Okay. Now, one more thing. This subnet is always assigned to one availability zone. In the previous slide, I forgot to mention one thing, that a VPC is something that belongs to a region. Okay. Whereas a subnet belongs to a availability zone. Okay, I hope this makes sense. It can't spam across multiple AZs, one AZ, one subnet. Okay, and it is a range of IP address from VPC which are getting assigned for a specific application. Simple. So hope you have understood the idea of subnets over here. So we are also going to create these subnets, but in our case, we won't be creating any private subnets. We'll just be creating two of the public subnets. Okay. Since we are not making use of any databases or other applications which shouldn't be accessed. Okay. So let's move on to the next topic. Now the next topic is about internet gateway. Now first of all, again, its name is internet as well as gateway. What does it mean? It is acting as a gate for the internet. Okay, so basically, if the resources within the VPC want to have an access to the internet, then we require this particular internet gateway. And this internet gateway is attached to the VPC, directly attached to VPC. Okay, so it allows the external traffic to enter our VPC. Okay, so this one is also very simple. It's attached to a VPC and it allows the network traffic to enter our VPC. Simple? Okay, I hope it's clear. So I'll be moving on to the next topic, that is router. Now basically, routers are specifically take care of routing within the VPC and outside of a VPC. It basically allows the network traffic to go in the right direction from a subnet or an internet gateway. For example, let us take some other color. Okay, now if you can see that our internet is coming through this particular gateway, right? Now it is coming till here. Now this internet gateway also provided the access. Now it's entering our VPC, but it doesn't know where to go. It's coming here, but it doesn't know that which application I have to route this traffic to. So in order to provide that particular direction to the network traffic, what is happening is we create a router, and this router then allows the network traffic to go into the right direction. For example, if this traffic is supposed to go to this particular public subnet, then with the help of route table, it will reach to this. It takes care of all routing for connections that are going even outside of the subnets as well. Okay, so you don't see the VPC router, all you see is a route table as well as route table associations. Okay, so basically route table is something we create in our AWS. So while while writing a Terraform code, we are going to create these route tables as well as route table associations, with the help of which we'll be associating our route tables to this particular subnet. Okay, and our route table will contain this internet gateways. Um, you will be getting confused if I go in more details. Just try to understand that it will just give your traffic a direction to your application within the VPC, as simple as possible. Okay, so just this is the work of your route table. Now now you all must be knowing about an EC2 instance. Do you know what does EC2 stand for? So basically EC2 stands for Elastic Compute Cloud. Now what is it? It is simple server. You can say it is as a logical server since it's not physically visible. Yeah, but it is providing you all the features like a physical server. Okay, which is provided by AWS to us. Simple. We have created this EC2 instances earlier also. So if you don't know how to create an EC2 instance using Terraform, you can go and check that video. It is really helpful for all those who are just beginning with Terraform, and that's it for that. Now the next topic is about load balancers. Now this is a very crucial thing. So before trying to understand an application load balancer in AWS, what we can do is we can first try to understand what is a load balancer. What is it? Yeah. So basically, consider you have got a one server. Okay, I'm just trying to give you a brief thing since I don't have much space over here, but listen to it carefully. Okay, so now traffic is coming to this particular server, that's fine. Okay. Now, what happens is if your application goes viral or anything that you have uh, used your server for, it is going crazy. Like the number of people accessing this application got increased suddenly. Now there is some capacity of your EC2 instance, like in our case of T2.micro, there is some capacity of CPU, there is some capacity of memory allocated to it. Now, about this particular capacity, it won't do anything. It will give up on the task and it will say, no, no, this is out of my capacity. I can't work more. Yeah. So that's the thing. Then what happens is your application, your server goes down. Yes. So in order to avoid this, they came up with another idea. Like if instead of one single server, if we have one more server to it, or if we allocate a group of servers to it, yeah, so that if this one is not working, there is someone else that is working. Yeah, so this is how we attain availability in DevOps. Okay, now in order to distribute the work equally, or we can say according to the capacity and usage, what the application load balancer or just the load balancer does is, now suppose this server is busy, this one is also busy, in fact this one is also overflowing with the request, and this one is idle. Now if the request comes externally, it will first transfer, or we can say it will um, redirect that request to this particular server since it's empty. Yeah, so basically what is the work of load balancer? As its name suggests, it is balancing the load between the servers. That's as simple as possible that I could explain this topic. If you have any doubts regarding this, you can definitely reach out to me using LinkedIn or Instagram or any other platform, or even the comment section. Yeah. So basically keep it in mind, load balancers are used to balance the load between the servers. It doesn't leave any of the servers idle, and it doesn't overburden any of the servers. So that is what is required, right? And for doing this, it has got multiple algorithms. Yeah, there are multiple algorithms available with the help of which our load balancer functions and accordingly balances the load. Simple, that's cool. So you now must be clear with application load balancer. So for understanding the load balancers in AWS, we have got few components available for it. That is listener. A load balancer has a listener. It has got a target group. Okay. Now basically what is a listener? So basically a listener is something where our traffic comes to. Whenever the traffic comes to the load balancer, it will be distributed to these listeners. That is, these are the components that receive the request. So they have got some sort of rules. Yeah. So that is what a listener is. Now the listener on listening redirects the traffic to the target groups. Okay. So target group is something where the request is being redirected to, and these target groups are then attached to our EC2 instances. You can have a single target group as and multiple EC2 instances within that single target group as well. Okay. So that is what is important. And for in Terraform, we have got a listener, we have got a target group. We also create an application load balancer, and at the same time, we have got target group attachment as well, with the help of which we attach these target groups to our EC2 instances. So this is via target group attachment. Okay, so this is all about our load balancers. Hope this is clear because these concepts are really important. So for those who are starting, I would like to uh, request you that please go through this video. It will really help you um, with a basic knowledge. Yeah. So let's move on to the next slide. Yes. So now this is what we are going to create in our project. Okay. So basically what are we going to do is we are first going to create a VPC. VPC first. Yes. Then after creating a VPC, we are going to create these two subnets. Then within the subnet, we are going to create these EC2 instances as well. Yeah. We are also going to create this internet gateway. We are also going to create route table, which I haven't shown over here, but it's still there. Then we have got a load balancer, which will be, balancing the load between these two servers. Yeah, we will also be creating these two security groups out here, which is really important. Yeah, so basically this will be the architecture of our project. Okay, so we will be referring this one for our project. Now the next thing is about the project execution flow. Now how will be the project execution flow? So first thing first is we are going to first write a Terraform code in our VS Code, which will be then deployed to our GitHub repository. Okay, so we'll be creating a GitHub repository specifically for this task. Okay, and once the see, we will be having branching strategy. Okay, wherein we will be having two branches. First thing is a main branch, and the other thing is a feature branch. Okay, so first, we'll be deploying our code to the feature branch, and once we are confident enough, we'll be then pushing our code to the main branch. We'll be raising the PR and all such stuff, right? Now, once we push our code to this particular main branch, what will happen is our GitHub Actions will get triggered. Now, this GitHub Actions will contain all the Terraform commands, like all the stages, that is Terraform init, Terraform plan, Terraform apply. Okay, and with the help of Terraform apply, all the changes will be deployed to our AWS account. Okay, so this will be our execution flow. This is really a simple project, but it is really interesting once we start working upon it. Okay, so let's move on to the next slide. Now we are going to talk about our code, like how will be the Terraform code structure. So basically, how will our structure look like is we'll be making use of modules. So basically there will be four modules. First is a VPC, second is an EC2, third is a security group, and fourth one is our load balancer. Okay, so these will be the modules that we'll be creating. So you can see over here, this will be our VPC. This is my folder, VPC using Terraform. This is my folder. Now within this folder, I'll be having uh, another folder that is Terraform. Yeah, and one will be like .github slash workflows, and within this so these two will be my primary, these things what I say is folders, and within this Terraform folder I will be having a folder named modules. Within the modules, we are going to have our four modules available, that is VPC, EC2, SG, as well as ALB. Okay, so these will be our modules available. And further, we'll be having our main.tf file. Then we'll be having all the other things like variables.tf. If you want, terraform.tf vars will also be present over here. Okay, we'll also have provider.tf. Okay, so all these things will be available over here. So you don't need to worry, we'll be going through it stepwise, so it will be very easy for you to understand it. And within this GitHub/workflows folder, we are going to have our deploy.yaml, which will have all the details for our CI workflow. Okay, so that is the thing. This is really simple and you all are going to enjoy it. It is really worth learning. And this, if you put it in your resume, it is going to add value to your resume, and it definitely help you learn as well, not only just for showcasing but also for learning. It is one of the important projects. Okay, yeah, so this is how will be our Terraform code structure. Okay, so let's move on to the next slide. Now, what are the prerequisites? Now, this is another important question that most of us will get before start writing the code, right? So the first thing is you must have AWS account. You must also have a GitHub account. Okay. The second thing is you must have Git installed on your machine. Git plus Terraform as well installed on your machine, though you don't need it, but for testing purpose you may need it, right? Because we are going to deploy it using GitHub Actions, so you don't need to worry, but for testing purpose you may need it, and it's always better to have it installed for others as well, so other tasks as well. So it would be better if it is already installed on your machine. It will really help. Then you must have got Git installed as well. You must also have uh, AWS CLI configured. Okay. Third thing is you must have a good idea about Git. Okay, how the Git works and all the commands related to Git. You must also know about a brief or the basics of Terraform. If no, then you can just go and watch my previous videos wherein I have explained all the steps, or the what we say, the different stages of Terraform, that is init, then plan, then apply, validate, and so on. Okay, so that is required. Okay, and you must also have got an access key for your user account of AWS, since it will be required. Okay, so these were the things that will be required before actually starting. So I hope you found it useful. So, without wasting any time, let's go to the console or our Windows screen and then start coding, so that it's going to be a huge fun. Okay, so stay tuned. So now that we know the prerequisites of our this project, the next step that we need to do is we need to create a GitHub repository. So for creating a GitHub repository, you must have a GitHub account already present. If you don't have any account, what you need to do is you first need to create the account with the help of your Gmail ID, and then after that just go to the repositories section and then go into the new repositories. Now in this, mention the name VPC Terraform GitHub Actions. Okay, then I'm just giving a simple description over here, wherein we are just creating a VPC using Terraform as infrastructure as a code and GitHub Actions as CI/CD pipeline. Okay, and I will be keeping this repository public. I will also select this add a README file option. Okay, and we'll be creating this repository. And you can see that our repository has been created. Now what I'll do is I'll just try to clone this particular repository in my projects folder. For this I will be trying to open git bash, and for this you must also have git installed on your machine. Okay, so just do git clone and paste the link. Okay, and now you can see that the repo has been cloned and this particular folder has been created, that is VPC Terraform GitHub Actions. Now let's just move into this particular folder. Okay, you won't see anything other than readme.md. Yeah, so now what we are going to do is we are now going to create another branch. We are not going to directly make changes to our main branch because it is not a good practice, so mostly in most of the organizations main is directly linked to your production environment, so it is not a best practice to directly push your code to main, right? So before actually pushing it into the main, what we can do is we can just create a new feature branch and add the changes to it, test it, and if the changes are valid enough, then we can merge it to main. Okay, so in this we are going to code in our feature branch. So now you can see that this is our current branch. Okay, so now we are ready to code. But before starting to code, what is important is we also need to have AWS CLI installed on our machine. Okay, so let's check whether it's present in mine. Yes, it's present. So if you don't have AWS CLI installed on your machine, you need to first go and install it. Okay, and then after that, what we are going to do is we are going to configure AWS for the authentication purpose, right? So let me show you. Now you can see that this, suppose this is my local machine, right? Local, and this is my AWS, that is the cloud environment. Now in order to make changes, anyone can't make changes to your cloud environment, it must be authenticated first. So in order to authenticate, the thing that is required is you must first need to have AWS configured, and that configuration is with the help of access key. Okay, so first what you need to do is you need to create an access key, and after creating an access key you need to execute AWS configure on your local machine. Okay, so this is how things are going to work. So for that you just need to go to this particular AWS management console, go to IAM. Okay, and within this, in the access management section, go to the user section. I have already created a user. If you don't have any user, you can just go and create it. Okay, and within the security credentials, you have this section of access keys. So what you can do is you can just click on this create access key, select command line interface, then just I understand the above recommendation, just confirm it. Next, add the description whatever you need and just go and click on this particular create access key. Okay, so in this way you can simply create it. It's not at all a difficult process, and it will also ask you to download it, so better you download it for further usage as well. Okay, I have already created it. I have the CSV file with me which has got access key ID as well as secret access key ID. Okay, and now I will be using them to configure AWS. Now let's see how to do it. So just go and say AWS configure. Now it will ask me to enter the access key ID. Okay, so what I'll do is I'll just go over here, just copy this as it is. You don't need to add spaces. Okay, so just consider it without a space, otherwise it may give some problem to you. So just consider this and paste it right here. Okay, since I'm going to work in this particular region of US East 1 itself, I won't be adding anything over here. If you want to make changes to a different region, you can definitely mention that region over here, and I will keep the default output pattern as none. Okay, so now our AWS has been configured, and now we are set to write our Terraform code, right? So let's go to our folder. So now over here you can see that we just have a .git as well as readme. Now we need to add new folder to it for our Terraform VPC. Okay, and we are also going to add one more folder for our GitHub, right? Let me open this particular folder in a VS Code. You can use any ID as per your wish. I love VS Code, so I am just using it. You can use any of them. So now we have opened this in our VS Code, and now one by one we are going to first create a Terraform code, test it, and then we are going to create this GitHub workflow YAML file. Okay, so let's go stepwise. Now within this Terraform-VPC, we'll first try to create a file that is main.tf. There is another file that's required, that is provider.tf, for mentioning the provider. There is one more file that is variables.tf, and one more that's terraform.tf right? So these are the main files for our Terraform code. Okay, where we'll be calling all of the modules that we are going to create in this, right? So first of all, what I'll do is I'll first try to configure provider. So for that, what I need to do is I just need to go over here, type Terraform provider AWS, and simply go to this AWS provider, and in this just click on use provider, and you will be getting a typical format with the help of which you can directly create whatever is needed for you. So basically you can choose the version. I have chosen it to be the latest. Okay, so this is the latest version, and I'll be just pasting it as it is over here. Okay, so basically what is this is that this is a Terraform block, and within this they have mentioned the required providers. So if you are making use of Azure, we will be mentioning Azure over here. If you are making use of GCP, you will be mentioning that over here. So any provider that you want to use for your Terraform is mentioned right here, and few details of it, like what is the source and version of that particular provider, is being mentioned over here. And in the provider section below, here we'll be mentioning the region for our infra. Okay, so we are going to select US East 1. Okay, and I'll just save it. Okay, that's fine. And then after that, I'll try to create a backend. See, for the Terraform TF state file, we are going to store this TF state file in our S3 bucket. Okay, so for that we need to have an S3 bucket already created. So in the S3, you can see that I have already created a bucket over here. So what I'll do is I'll simply pass this bucket in my backend section. Simple. So let me open that backend code as well. With this, you will get a structure of this code, and now you can observe that this backend S3 is also present within the Terraform block itself. So we'll be just copying this particular section, be using it over here. And for the bucket, the name will be the bucket name that we have over here. So I'll be just copying it from here, and you can give any paths to it. Okay, so I'll be just kind of giving the path as, let's say, yeah, we can go for dev only. Dev Terraform main.tf state. Okay, and here is the region for our bucket, and that's it. So this is all about the provider information. Okay, and then after that, um, we won't be creating anything as of now or adding any of the values over here. So just this one is enough for now. And in the main function, we are going to call all the modules. So for that, we first need to create the modules, right? So let's go to the VPC folder, try to create a new folder, that's modules. And within the modules, we'll be creating different modules for each of the components, that is VPC, EC2. There's, sorry, I'm extremely sorry, new folder, SG, ALB. So these are the four main components that we are going to create in this particular project, that is VPC, EC2, SG and ALB. Okay, so what I'll do is I'll try to create another file, that is main.tf for my VPC, then variables.tf. We also have outputs.tf. So basically, these are the three files that are present in almost all of the modules. So you can also create them first and start working upon it. So now in the VPC section, what we are going to do is we are first going to create a VPC. Okay. Then after that, we are going to create subnets. Then after that, we are going to create a internet gateway. Then after that, we are going to create a route table. Then lastly, the route table association, right? So let's start with VPC first. So let's go to our documentation once again and search for AWS underscore VPC, and you will get this particular link available over here, and just change it to Terraform. Okay, and you will get this particular thing over here, right? So this is the resource block for AWS underscore VPC. Okay, so let's go and create it. So this is the resource AWS underscore VPC, and then I will be naming it as my underscore VPC. And in this, we are going to mention a CIDR block. Now, this is the most important for defining AWS VPC. This is the required field. Rest of the things, even if you don't mention, it's fine because they are optional. But this one is what is required. Okay. So for this, what I'm going to create is I'm going to create a variable for it. Okay. So let me create a variable. Let's give it a name as VPC CIDR. And within this, I will be mentioning the description being VPC CIDR range. Okay, and within this we are going to define a type, and its type is of course of type string, and you can also mention its value as default, or you can also pass it through the main.tf that is present directly within the Terraform underscore VPC, that is this one. Okay, so you can also define it here itself, or else you can mention it through this. If you want to mention it through this, what you can do is you don't have to mention the default value over here. Then what you can do is you just have to um, copy this value, this variable, paste it right over here, and give the value of VPC CIDR here itself. Okay, and just mention the value as whatever you want to um, have it. Okay, so this is the value that I have considered over here. I will be then going to the main.tf, mentioning the module section, and the module is like VPC first, then the source, and the source has to be mentioned. Source is nothing but the path to this particular module. of VPC. Okay, so since our VPC folder is present within the modules, what we have to do is we directly have to give this path. Okay, and just save it. And now we also need to give the VPC CIDR, which is var.vpc CIDR. Okay, similarly we are going to mention it as var.vpc CIDR. Okay, so in this way we can pass the values through the main function also, right? Not the function but the main file of our code. Okay, and then after that we will be making use of instance tenancy, which is to be, so that's what I'll be mentioning it over here. And then after that we'll be just adding tags to it, and the tags that I will be adding over here is name, which is equal to my underscore VPC. So this is the name that I want to assign it. Okay, now then after that we have got the subnet section. Now let's go to the documentation once again. And in here you can see that we have got this particular resource for AWS subnet. So what I'll be doing is I'll be just copying this as it is and modifying its values according to my requirement, right? So since I have to create two subnets, right, as per the architecture diagram, so for that what we are going to do is we are going to make use of count over here. So subnets, the VPC ID will be AWS underscore VPC dot my underscore VPC. Yes, and then after the CIDR block has been mentioned over here, but we can't directly mention it like this since we have to, uh, since we want two different subnets. So what we'll do is in the variable section, I will be creating a variable for the subnet CIDR. Okay, and I'll be mentioning the description as subnet CIDRs, and the type will of course be like a list of string. Now the same thing has to be copied to our variables of main folder, and in this what we are going to do is we are going to mention the value in this particular terraform.tf vars, where we are going to mention it as 10.0.1.0 slash 24 comma 10.0.2.0 sorry slash 24. Okay, so in this way we can pass the values through terraform.tf vars. Okay, now over here what you will do is in the main function you will create a count. Now what will be your count? It will be the length of your var.subnet CIDR. So whatever is the value of this will be the whatever will be the value of this, its length, the length of this value will be your count. Okay, and then after this you are going to mention the value with subnet CIDR, and since it is a list, right, so you will be passing the values of that particular list using this count.index. So this count.index will be like starting from 0 1. Okay, so if the count is 2, it will start from 0 and 1. If the count is 3, it will go from 0 1 2. So in this way it is going to loop this particular resource and create two different AWS subnets for us. Okay, with the respective these CIDRs. Okay, and then after that we also need one more thing since we want to create these subnets in two different availability zones, right? So for that what we need to do is we need to have a new file, that is data.tf, wherein we'll be mentioning the data as AWS availability zones. Okay, available. So you must have known about data, right? So basically data is something that will give you the values of the things that are already present on our machine. like the availability zones. So with the help of this data thing, what is going to happen is it is going to give me all the available, um, sorry, just I will be mentioning the state as available, right? So all the availability zones with the state available must be given through this particular data section. So I'll just save this, and now with the help of data I will get the availability zones, and these availability zones I will be passing it through this. Okay, now how am I going to pass it? I'll just say data dot AWS availability zones dot available. Now what are its names? We want the names, right? We don't want the IDs. So for that I will be considering the names and then count dot index. Simple. Now the names should also vary, right? So names are something that I will be giving it from here itself. So what I'll do is I'll again create a new variable, that is subnet names. Now within this I have to mention the description as subnet names, and the type has to be list of string. Then I will be mentioning the default values over here itself, that is public subnet 1, and once again a public subnet 2. So basically there will be two different subnets, okay, and both of them will be of type public only. We want them to be public, right? So I'll be mentioning these names over here. So what I'll do is I'll just mention var dot subnet names, and again count dot index, right? So in this way we are going to create two different public subnets. Okay, so now this one is also important, right? Now any subnet that we create by default is considered as a private. So in order to make it accessible to the network, we need to attach it to the, or we must give access to the internet gateway. And one more thing that is required over here is there is one more, I could say, a parameter, that is map public IP on launch. So this is very much important, because what it will do is it will specify true to indicate that instances launched into subnet should be assigned the public IP address. Now we are going to assign a public IP address to the EC2 instances that will be present in our subnet, right? Like, see, if you don't remember, this was our subnet, right? Say public subnet 1, and this public subnet had a small EC2 instance inside of it, right? In the diagram we had shown it. Now if we want public IP address for our EC2 instance, then in that case we need to have this map IP, sorry, map public IP on launch parameter to be true. Only then we will be able to create EC2 instances which will have public IPs. So this one is very important. So please make it a note of it. Okay. So we will be mentioning map. We already have it over here. We'll be just mentioning it to be true. Simple. I hope it's understandable and clear enough. Okay. So the next thing that we'll be creating is an internet gateway. So for the internet gateway, again we'll go to the documentation, and in this we have got this particular resource, that is AWS Internet Gateway. I will again be taking this thing as it is. Okay, let's name it as IGW, and let's also define our VPC, that is my VPC ID, and the name has to be like my internet gateway. Okay, so this is all about internet gateway. And in the diagram I had shown you that this particular internet gateway is only attached to the VPC, right? So that's why we are only considering VPC over here and nothing else. Okay, now the next thing is about route table. So we have route table resource as well. Okay, so I will be just taking this front thing. Okay, then we have got route table, my VPC, and the CIDR block over here. I will be considering 0.0.0 slash 0 because I want it to be public. Okay, so that's why I have considered it as the CIDR. Then after that we need to mention a gateway ID. So AWS Internet Gateway dot IGW is what is required over here, right? And that's it. So now let's go for our route table association. So let's go to, sorry, AWS. So this is my AWS route table association, and in this I will be just copying this path and pasting it right here. It is really very simple. Okay, so route table association. Okay, now the subnet that we want to create connect to. Now this is our VPC once again, right? And we have got this internet gateway. Now this internet gateway has to be attached to these two subnets, right? So we need to have two different route table associations. So for this we are going to make use of count. So let's do count. Let's consider count over here. So count is equal to the length of, let's consider var dot subnet CIDR. Okay, so the two subnets will be considered over here. So the first thing that we are going to consider over here is subnets count dot index, right? And the route table ID, right? So RT. So there is one route table, but the route table association will be two. Okay, so that is the thing. So let's save it, and I think we are ready to go. And let's try to go into this particular folder of Terraform. Let's do initialization first. So now we have done the initialization. Now the next thing that we'll be doing is we'll try to validate the code. Okay, there is some error over here. Now the argument is required. Okay, so I think I missed to mention it over here. Subnet CIDR is equal to var.subnet CIDR. Yes, it's working now. Now let's go for Terraform plan command. Okay, it's also working properly. Now let's go and apply the changes to check if everything's working right. So now we can see that the apply has been completed.
So let's go and check on the console of VPC. So within the VPCs, you can see that my VPC has been created, right? Then after that, we have got subnets. So there are two subnets, public subnet 1, which is associated to US East 1, and the other one, that is public subnet 2, is associated to US East 1B, which means that we have rightly configured these subnets in separate availability zones. Then after that, we have got route tables, right? Okay, so let me name it, okay, once again, because I didn't add any tag to it, because of which I'm not able to see the name. The name will be, let's consider my route table. Okay, so I'll be saving this. Once again, I'll try to apply the changes. There won't be many changes, just the name is something that needs to be changed. Okay, so the apply has been completed. So let's go to this and try to refresh it. And now you can see that my route table. So this is the route table that we have created. Okay, and the internet gateway. That is my internet gateway. Simple. So everything got created rightly, right? So now let's go to another module, that is the module of security groups. So similarly, you have to again create those three files, that is main.tf, then outputs.tf, as well as the variables.tf. Okay, so these are the things that are required. So yeah, and one more thing I would like to say that in the output section, we need to mention the output for the values so that these values can be used by other modules. Okay, so let me mention the value for VPC as well. VPC underscore, sorry, AWS underscore VPC dot my underscore VPC dot ID. So this is the ID of my VPC. Okay, and then after that, I'll be mentioning the IDs of my subnets as well. So subnet IDs. Okay, so this is something that you need to output so that you can use it for any other module wherever it's required. AWS underscore subnet dot subnets dot star dot id. Now why have I used star over here is because we have got two different subnets. So all the subnets that belong to this particular resource must be included in it, which will form a list of subnet IDs. Okay, so this is nothing but a list. Okay, so that's what I wanted to explain. Okay, now let's go to the security group for defining its main. So let's go to the AWS security group, and in here we are just going to consider this particular resource. Okay, so this is something that we are going to create. So let me change the names of these. So it has to be like security group, then the name of it is like SG only, I'll keep it SG. So it allows HTTP as well as SSH inbound traffic. So these are the traffics that we want to consider. Now over here they have asked to enter the VPC ID, but we can't directly go and mention it like this. See, most of you may try to do this way, right? That is AWS underscore VPC dot my underscore VPC dot ID. But this VPC main.tf belongs to another module, and one module is not accessible by another module directly. So in order to pass the value of this particular VPC ID to the SG, what we need to do is we need to first output this value, that is VPC ID, which we have already done through our outputs.tf, right? So this has been done. Now after this, what we need to do is we need to create a variable over here. So let's create a variable, that is VPC ID. Let's define the description over here as VPC ID for security group. Then we also have a type. So its type will be string only. Okay. You won't be mentioning the default value here. Okay. Because we need to pass it through modules. So how are we going to pass it? See, over here, you have to first of all remove this. Okay. We have defined a variable VPC ID. So just copy it. Whatever name you have given, just copy it and paste it right over here. var.vpc id. Okay. Uh, in the main folder, what we have to do is we have to mention a module for SG. Okay. We'll define the source as dot slash module slash SG. So this is going to be the path to this particular module of SG. And then after that, we are going to pass VPC ID, and this VPC ID will come from this particular module's output, right? So what I will be mentioning here is module dot VPC dot VPC ID. Okay. So in this way, we have passed the value of VPC by outputting this particular VPC ID from VPC module and then passing it onto our SG module. Okay. So this is how it is going to work. Simple. Even if it's not clear, I will try to explain it once again. Okay. So let us consider that you have got one module that is VPC. I will take the same example. Okay. No need to worry about it. And the other one module is of say SG. Okay. Now you want the VPC ID over here in SG. These both of them are modules. So both of them are modules. And now we want to have the VPC ID of this particular module as a value to one of the mod resources of this particular module of SG. So what we'll be doing is we will be mentioning it in the output section of this particular module like VPC ID. And whatever the value is, we are going to mention it as it is. Okay, simple. And after outputting, what we are going to do is in the main section, what we are going to do is we are first going to define the module of VPC. Sorry. Mm, So this is the VPC, right? And in this, we are first going to define a module of VPC. Then we are going to define a module of SG. Okay. And in this, what we are going to do is, if we wanted to pass this VPC ID, what I'll do is, I'll consider module. From which module? From VPC module. Now over here, you don't have to take this VPC. You have to take what you have mentioned over here. So if you have mentioned like VPC network, then over here also you will have to mention VPC network. Okay. So this is very important to understand. So you just have to mention the VPC since it's VPC over here, right? And then after that, what you will mention is the value of this. That what you have mentioned in the output and not of this. This is not to be considered. You have to consider this only, that is VPC underscore ID. So this will form my module SG with the right input of VPC ID coming from the output of our VPC module. Now hope it's clear. I think I have explained it in a better way. Okay. So if you have any doubts, you can definitely ping me in the comment section. I will definitely try to reply it. Okay. So that's fine now. Okay. So over here in the ingress in the sense inbound rules. Okay. So for ingress, we want two rules to be mentioned. One for HTTP and the other one for SSH. Okay, so simply what I'll do is I'll be mentioning the port over here as 80. Again, it should be 80. Okay, I will be removing this, and the CIDR block that I want to mention is for the public access, so I will be just mentioning this one, right? Then after this, since I want to define ingress rule for SSH as well, I'll just copy it and I'll be just changing the values over here. So always the protocol for SSH is 22. Okay, the rest of the things I'll be keeping it as it is. And also I won't be bothering for IPv6 as of now. I'll just try to change the name for the security group. Let's name it as my security group. Okay, so I'll be saving it, and our security group is ready. Okay, also this security group is something that will be adding to our EC2 as well as ALB. So for this, what we need to do is we need to mention it in the output section once again. So what I'll do is I'll be mentioning here output sgid. Okay, and then we'll be mentioning the value, which is AWS security group .sg.id. Okay, so do this first, and this is the variables. So fine, so this is what we have included in here. Okay, for the SG. So I hope my SG is fine with it, and I will try to create it once again. Okay, so don't do like you are creating everything and then you are applying the changes, like you are writing the whole code and then you are applying the changes. Please don't do that way. So go stepwise, module by module, so that you will know what the actual error is in a smaller context, and it would be very easier for you. Okay, so now let's try to validate the code. Okay, then after this, let's try to plan it. Then let's try to apply the changes. So it is only going to create security groups since the rest of the things is already been deployed, right? So let's go and check whether our security group has been created or not. So let's go to the EC2 section. So in this, let's go to the network and security groups, and you can see that this is the security group that has been created. And within the inbound rules, you can see that we have got HTTP as well as SSH, both of them. Okay, so our security group has been successfully created with the required inbound as well as outbound rules. Fine. So now let's go to the other thing, that is EC2. So again, we are going to create three different files over here, right? Okay, so these are the three different files. And in this, I'll first go and create an EC2 instance. So for that, what we need to do is we need to go to the section of EC2. You can see it over here. Go to the AWS instance. It's here. Okay. And in this way, we'll get to this. Okay. Now over here, you can see that in an EC2 instance, we require an AMI to be used in order to create the EC2 instance, right? So in this, what they have done is with the help of data, they have taken this particular AMI by filtering it out with different conditions and then just using that over here. So we also can use it like that, but we don't want Ubuntu, we want Amazon Linux, right? So for that, we'll try to search the data section or the data resource AMI for this particular Amazon Linux. So let's see what we get. So over here they have just given the same thing. Okay, let's use it. So over here also we will have to create data.tf wherein we are going to mention the data field. Okay, so these are the things. We also want the virtualization type to be like HVM, right? So that is what has been mentioned in here as well. So I'll just use this over here, the filter. Okay, so in this way we can make use of it. I'll just try to. So this is Amazon 2. Anyways, it should just be for Amazon Linux, and I think that it's fine. Okay, so let's keep it, and we will also need the data for availability zone. Let's name it again as available, and in here we'll be defining the state as available. So whatever is available, just give it to me. Yeah. Then after that, we are going to just define this resource. Okay. So in this, the data will be different in our case. It will be like Amazon2.id. Yeah, it should be t2.micro in my case. And what else do we need to define in here is we have to define the security group, right? So what I'll be doing is I'll be mentioning the VPC security group IDs, and this is something that needs to be passed as an array, right? So we'll be mentioning it in the square brackets. So what I'll do is we need to pass the security group from this module, right? So what I'll do is I'll define a variable of it once again. So variable sg underscore id, okay, and the description will be like sg id for ec2, and the type has to be of type string. Okay, so we have done this. Now let's define the same. No, no, we don't need to define anything anywhere. So just try to mention this thing over here and just go to your main.tf of your main folder and just mention module ec2, and within this you mention the source as dot slash modules ec2, and then we are going to pass the sg underscore id from module dot sg dot sg underscore id. Okay, so in this way we pass the value of this particular sg id to this module ec2, right? So this was it. We also want to associate ip address, public ip address, to this particular ec2 instance, so we'll be making use of associate public ip address, right? And mention it to be true. Fine. Then what else we need to define is a subnet ID. Now again, the subnet ID has to come from VPC module, right? So again, we are going to define it over here in the variable section. So in the variables, we are going to define the subnets, and in the description, we are going to mention it as subnets for EC2, right? And one thing I definitely forgot over here is we need to we need to create two different EC2 instances. So it has to be of count 2, right? So that is something that we need to define, and tags will also vary with it. So the subnet, so this is a list, okay, list of string. I will be just saving this one and mentioning it as var dot subnets count dot index. Then again I will go to the main.tf, and in here I will be mentioning subnets, and what I'll do is I'll take the subnets value from module.vpc.subnet IDs. Okay, and in here again I have to define the EC2 names also, right? So two different names for the both of them. So what I need to do is I can just mention, yeah, I can just do create a variable for EC2 underscore names. Okay, I will be mentioning the description as EC2 names, and the type has to be of list string, and I will be mentioning their values here itself. Okay, so the values will be like web server 1 comma web server 2. Okay, so I'll be just giving these names, and in here I will be defining it as a length of var dot ec2 names, and these names will be mentioned over here in the count dot index. Okay, and one more thing that I will be adding over here is a user data. So basically, what is a user data? If you don't have any idea, let me explain it in short. Okay, so basically you can see that you have got an EC2 instance, right? Now in this EC2 instance, this EC2 instance is made up of uh, images, and these are plain images which belong to the operating systems, right? If it's Ubuntu, then it is going to have that particular image. If it's Amazon Linux, then it has got the respective image, right? Now if we want these instances to have certain requirements before we actually run the application, then we need to execute few commands, right, on it, to install certain things or to configure certain things, right, for configuration purpose. So what is done is, at the boot up period, like once the instance has been launched, you can make use of user data, which will have a certain set of commands. Okay, and these commands will be executed as soon as your instance is ready, and when you deploy your applications will be running on them easily, because all the requirements will be fulfilled by the user data, right? So user data is nothing but a set of commands that needs to be executed once your instance is launched. Simple. So that's it. Okay, so this is what I will be mentioning in here. User data has to be mentioned in the form of EOF, that is end of file, in this way. Okay, and whatever needs to be written has to be written in between of. So basically I have already got this particular user data, so let me open that file. I have already downloaded this. Okay, so over here you can see, let me open it with, so now you can see that this is my user data. Okay, so basically I have already created this uh, so that you can view something in the UI once we access our EC2 instance. So for that purpose, I have tried to made it a bit presentable, so you can watch it. So basically you can see that this is my user data. So these are certain commands that I want to execute once our EC2 instance has been up and running. Yeah. So this is basically to see something in our UI once we actually access it via public IP. So what I'll do is I'll just copy this whole stuff, and I will be entering everything over here. Okay. So everything I have mentioned in here. Okay. Just try to add a tab space once so that it will look a bit presentable. Okay, So it has got nothing. You can also start with the basic commands also. That's also fine, okay? I wanted to see it in some kind of format. That's why I have added this. If you want this code, I will be pushing this particular code in the GitHub account. So you can watch it from there as well, okay? So I'll be saving it, okay? We are quite done with it. And one more thing that I have missed over here is about the availability zone. And that is something that we'll be getting it through the available dot names, and over here it will be count dot index. Okay, so over here these are the things. Okay, okay, so now let's save this. Let's go to the output section, then try to output these instances. So let's make it as instances and put the value as dot star dot id. So again, it is also going to give me two IDs, each of the instances, right? So that's it. Let's go to the this thing. Everything is done. I hope it's so. Let's try to init it once again. Now, in this case, our EC2 instance will be initialized. Not instance, but the module of our EC2 will be initialized. Okay, there is some sort of error over here. So basically the problem was that we need to mention not just the availability zone, but the availability zones. Okay. Similarly, over here as well, I had just mentioned availability zone. So that's why it was giving the error. Now if I try, let's go and try to implement. Yes, now it's not giving any error. Okay. Now what we'll do is we'll mention the apply auto approve. Okay, so the changes have been applied. Let's go and check it out. So in the instances section, we can see that two of these instances have been created in each of the different availability zones, right? This is what we needed. Okay, so let's wait for them to be like ready. Yeah, so it's in an initializing stage. Till then, what we can do is we can go for the creation of an ALB. Okay, so let's close all of the other modules and let's create three main files once again, that is main.tf, then output.tf. Sorry, it should be outputs. Okay, that's fine. And again one more file, that is variables.tf. Fine. Now let's go one by one. So let's go for the ALB first. Okay, so we have got elastic load balancing section, and in this we have got AWS LB. So what I can do is I'll just grab these few things, okay, for my AWS load balancer. Okay, now just rename these things, that is ALB. Then we have to mention the name for our application load balancer. Okay, it's not an internal, it's an application. Now again, for the security groups, we want the security group to be taken from here, so from this module. So what we'll do is we'll just remove this. We'll go to the variables, define a variable, okay, and just mention it as sgid, description as sgid for application load balancer. Okay, the type is of string itself. Yes, so just save it. Now let's go to the main section. Just mention var.sg underscore id. Okay, so now it's done. So let's go to the main folder. Mention the module alb over here. Mention the source. Okay, and in this, the first thing will be the path. And then after that, what we are going to mention is a sg underscore id, which will again come from module.sg.sgid. Okay, so we have successfully passed the security group. Similarly, we'll also have to pass the subnet id. Okay, so again, what we'll have to do is we'll have to go in this section, define the variable, define it for the subnets. Then the description will be subnets for alb. Then we'll be mentioning the type, which is of course of type string, list of string. Okay, so we'll be mentioning var.subnets over here, and the same thing will be passed from here, which is module dot vpc dot subnet ids. Okay, so two of the subnet ids will be passed to the alb. Okay, and then we have to, I don't need this. Okay, so I will be keeping the things as it is for now. Okay, yeah, fine. Now let's go and create. So over here we have created an ALB first. We will now be creating listener. After that we'll be creating a target group. And lastly we are going to create a target group attachment. Okay, so let's go stepwise. Now let's go for this listener. So let's grab this code. See, all you need to understand is what parameters to be passed when. Only that is important over here. Once you know that, it is going to be very easy for you. The port that we want is 80. See, if you are working with HTTPS now, you need this SSL policy as well as certificate ARN. But now we are not working with HTTPS. We are trying to keep it simple by considering HTTP. Okay, so that's quite manageable. Okay, and you don't need the SSL policy as well as certificates and all, etc. Okay. Now, in this target group ARN, we need to pass the ARN of target group. So what we need to do is we first need to go and create a target group so that we can pass the ARN over here. So there is a target group section as well. So let's go and try to create it. See, no, this one is what I want. See, there are multiple types of target groups. So the other one was of IP target group. So this one is for the instance. Okay. So let's name it as TG. Let's name it as ALB underscore TG, or let's go for TG only. That's fine. Okay, then the VPC is what we need to. Now again, we can't mention the VPC as it is. So what we have to do is go into the variables. What I can do is I can just copy this, okay, and I'll just modify a few things like VPC ID, and it is just of type string, and save. I will be mentioning var dot VPC underscore ID. Okay, let's go to the main. Then in this VPC underscore ID is equal to module dot VPC dot VPC ID. Okay, then it's done, I think. Okay, now we need only one target group, but we need two target group attachments. Why? Because each of the attachments will be connected to an EC2 instance, right? So one target group is attached to two different instances. Okay, so then let's go over here, go to the target group attachment, and in this case, just grab one of these resources, then just define the, or just change the name of it. Just use the TG over here. Similarly, don't forget to mention it here as well. Okay. Now, there is a target ID. Now, this instance ID is also something that is not, um, that does not belong to the same module. It belongs to the EC2 module, right? So what you need to do is you need to again create a variable of type instances. Okay. And in here you will be passing the description, instance ID for target group attachment, right? And again the type will be of list, right? Then let's go to the main.tf of load balancer, and in here we will be defining the count. The count is going to be var length of var dot instances, and what we are going to do is we are going to pass the var dot instances dot index. So this will be our target ID and the port will be 80 only. Okay, so then let's go to the main.tf and again pass the instances as module.ec2.instances. So in this way, we have passed these instances to as a instance or the target IDs for our AWS target group attachments. Okay, so these are the things that we have created. Simple. I hope it's really clear to all of you, and it's quite easy also. So I don't think you would be facing any problems, and if you face, you can definitely ping me. So I'll be initializing it once again. Let's plan it. Okay. So now let's try to apply the changes. So now the apply has been completed. So now let's go to our console and let's try to access the things. So let's start with the EC2 instance. So we have got this public IPv4 address. So what we can do is we can go and try to access them. So now you can see that this is the user interface, and this only is visible because of the user data that we had mentioned in our EC2 instance, right? So you can see that when we try to access this web server one, we get all the details related to the instance ID, the t2.micro or the instance type, then the availability zone in which it is operating. Okay. Similarly, it would be visible for web server 2 as well. Okay. So let me show you this as well. So you can see that this one is running in US East 1, US East 1B, right? So, and this one is in 1A, right? Now, if we try to access the same thing using a load balancer, you will understand the working of application load balancer. Okay. So if I try to access the same thing using application load balancer, then you can see that it is directing the traffic to 1B first. Okay. If I refresh it, it's still passing to 1B. Now it's passing to 1A. Now again 1B. Now again 1A. So it is trying to balance the traffic between both of these servers so that everything is distributed properly and none of these servers are overloaded. So this is how we have successfully created all the required resources. So what I'll do now is let's try to delete or destroy this infra first. Okay. Now, why am I destroying it is because we want to deploy the same thing using the CI/CD pipeline. So basically, what we are going to do is we are first going to see this is what is our Terraform VPC, right? Now, this code, what we did now with this code is we manually tried to automate the infra, right? Now, what we want to do is we want to deploy this Terraform also in an automated fashion using GitHub Actions, right? Now, all the steps that we were following, that is Terraform init, Terraform apply, sorry, before apply plan, Terraform apply. So, all of these steps will be included in this particular GitHub Action CI/CD pipeline. So, we don't have to do even this manually. Okay. So, for that, we'll be first creating a workflow or a deployment file which will be present in this particular folder, that is GitHub slash workflows slash deploy dot YAML. Now in this particular YAML file can be named according to your will. Okay. But it should be under this section. This is very important. Okay. It should be present within the .github workflows, and this .github should directly come under this particular repo. Our repo, this is my repo, suppose. Then within that repo, I should have this GitHub. Okay, then only it will detect it, else it won't. So this is what is important. Okay, now in this deploy.yaml, we are going to define all the steps that the CI/CD pipeline needs to follow to deploy the infra on our AWS, right? So let's go and create this file for us. Okay, let's close this. Let's close all of these files. Okay, now let's go to .github. Now create another folder, that is workflows. It is important to have workflows folder within this, and within this folder of workflows I will be creating deploy.yaml, which is my declaration of pipeline. Okay, so first of all I will be defining the name for the pipeline. Let's say the name is like Terraform CI CD pipeline for deploying AWS resources. Okay, and then we have got run name as well. So this I will be defining it as github.actor. So basically this is nothing but a environment variable you can consider which detects the name of the one who has made changes to the pipeline. Okay, has triggered the pipeline. Okay, now when should this pipeline start? When should it be triggered? It should be triggered when there is any push to the branch of. Now when I push this code to the main branch, I wanted to trigger the pipeline. Okay, so I have mentioned main over here. Now I will also be defining the environment variables. So I am going to define two different environment variables over here, that is AWS access key as well as AWS secret key, secret access key. Now you must be questioning me, why are we defining these environment variables once again, whereas we have already configured it on our machine? Exactly, we have done it. But what is the problem is, see, when you were on your local machine, say this is your local machine, okay, and you wanted to make changes to the AWS. So what you did is you went through AWS configure, and this configuration is done on the local machine. Now we want to make changes through GitHub Actions. Now the GitHub Actions is unaware of these access keys. Then if we directly try to apply the changes over here, AWS will say, who are you? If you don't know me, then how can I allow you to make changes in my environment? Right? So GitHub Actions has nothing to do with this AWS configure. So it needs to have these environment variables wherein these access keys are defined. That is AWS access key as well as AWS secret access key. Okay. So these two things are important that we need to mention in the env section of our deploy.yaml. Now, how are we going to pass it? That's a good question. We need to pass it, right? But how to pass it? So, what we are going to do is we are going to our GitHub account, the repository, then go into the settings section. Go under the security section, you have to go into the secrets and variables, and under this, go to the actions. Within that, you get this action secrets and variables. Just go to the new repository secret. Just consider AWS access key. Go to what you have installed on your machine, that is access key that you downloaded earlier. So just paste it over here, add the secret. Again, consider the secret access key, just copy it. Then go to the new repository secret, consider this AWS secret access key, enter this value, add secret. So these secrets are available in our repository secrets. Okay. Okay, now we have defined it, but how to make this pipeline aware of it? So in order to make it aware, what we are going to do is we are going to define it as a secrets dot AWS access key. Okay. And then after this, secrets dot AWS secret access key. Simple. So both of these environment variables are now known to our pipeline. Now we are going to start writing our jobs. Now the logical name for this particular job will be like build infra, and then I will be defining the name of it. That is, let's consider Terraform CI/CD. Okay, then it runs on Ubuntu. Let's consider Ubuntu as the runner for our GitHub Actions. Then after that, we'll be defining the steps, and within the steps, I will be defining the first step, that is checkout. Now, you must be knowing what is a checkout, right? So basically, it is used to go into the or to fetch the repository where we want to on which we want to work upon, right? So it is going to make use of actions slash checkout at the rate v2. So this is the plugin that is used for checking out. Okay. The next step is to set up Terraform. Now, this is a plain Ubuntu image, right? It doesn't have Terraform installed on it. So in order to set up Terraform, we are going to use another plugin, that is HashiCorp slash set up slash Terraform, sorry, hyphen Terraform at the rate v2. So this will be the plugin that we are going to use in here. Now, once we are done with setting up our Terraform, what we have to do is now we can start with executing our Terraform commands. That is Terraform init will be our first step. Then the ID will be of course init. Then after that we'll be defining the command, that is Terraform init, and also we need to define the directory, since this Terraform is not in the current directory, right? So for that matter, we need to define the directory where the things have to execute. Again, we'll go for this name. What I'll do is I'll just try to copy the same thing. The only thing that differs is the command, right? So let's try to just, so I will be trying to validate it. Okay. Now again, I'll try to use the same thing. It's easy actually, very easy to understand. Even if you are using GitHub Actions for the first time, even then it won't be very much difficult for you. It will be easy. Okay. So then just plan it. And then after that, again, what you need to do is apply the changes. And with apply, you also need to mention this auto approve so that it gets automatically approved and moves forward. Okay. So now let's try to push the code to our feature branch first. So let's try to clear it up. Let's try to check the status. So everything almost needs to be tracked, right? So git add dot. Okay, one more thing I missed over here is I need to create a git ignore over here, okay, wherein I have to mention what all files I don't need to push. So this is Terraform that we don't need to push, okay, to our remote repository. Also, we can't push .terraform .lock .hcl. Okay, so this is the thing. These are the two things that we can't push it. Okay, so let's try to git add is done. Um, Or else what I can do is I'll just try to remove this. Okay, let me check the status. Okay, so now let's add these things and let's commit these changes. So git commit -m adding Terraform and GitHub action files. So these got committed. Now after this, I will be trying to push these changes to my feature branch. Now everything has been pushed to my feature branch. Let's go over there and check it out. Okay, so in the code section, let's change my branch to feature. And over here you can see that, okay, but I can't see the GitHub actions as well. So for that, okay, I just need to go out of it. And now I think it would be much feasible now. Yeah. So now git commit -m adding GitHub actions workflow files. Okay. Now let's try to push it. So now GitHub actions file is also pushed. Okay. Let's try to refresh it. And now you can see the .github workflows folder as well as this Terraform-VPC code over here, right? Now what we'll do is we'll try to compare and pull the request, raise a PR, okay? Okay, so let's create a pull request and now we'll be merging, okay? So confirm merge. I won't be deleting the branch, okay? Now, since we have pushed the code to main, now our GitHub Actions pipeline must have been triggered and you can see that it has already triggered and it's already running. Okay, you can see that validate is working. Now our plan is executing. It has been executed. Now apply is getting executed. So in this way, we can deploy the changes to our AWS with the help of GitHub Actions. And it's working as well. You can see that everything is getting created. So hope you guys found it really helpful. You can add this project in your resume and make it and really showcase it, and it is really beneficial, and I hope you really enjoyed this and you learned a lot from this. So if you like this video, please um, let me know in the comment section. Also, if you have any doubts, you can share it with me. And if you like this video, please like, share, and subscribe to our channel so that I can come up with more and more such content on the daily basis. Your support is really required. And we have noticed that most of you have not subscribed to us. They are just watching and leaving the channel. So it's a humble request to all of you that if you found the content useful, please like, share, and subscribe and stay tuned. Thank you so much.